Born on May 12, 1910, Dorothy Hodgkin was born in Cairo, Egypt, to John and Grace Hodgkins, British citizens working in Egyptian education services. They returned to England when she was 4 years old and later moved to Sudan to focus on archaeology. Her father became the director of Jerusalem's British School of Archaeology, while her mother was a botanist. She illustrated and took note of the flora in Sudan. Dorothy stayed in England for primary and secondary school, and she visited her parents in Sudan frequently. It was during those visits that she was exposed to and studied minerals and crystals, while her parents helped out with excavations. Both her parents practiced and believed in selflessness, which will later contribute to Dorothy's work in numerous organizations.
Dorothy Hodgkin attended Sir John Lemon's School in Bessel, Suffolk, England, when she was about 10 years old, from 1921 to 1928. This is the place where she first found herself becoming attracted to chemistry and decided to become a chemist. She was accepted as a chemistry undergraduate student at Somerville College, University of Oxford, at the age of 18 in the fall of 1928. The first year at Somerville College, she studied how to analyze glass tesseracts. In later years, her interest of study shifted from X-ray crystallography. She worked with H. M. Powell, who was doing research in thallium dialkyl halides. Her interest in chemistry continued to develop as she met with Dr. A. F. Joseph, who then inspired her to study the structure of sterols. In the spring of 1932, she graduated with a Bachelor's of Science degree in chemistry from Somerville College, University of Oxford. Afterwards, Dorothy Hodgkin started to pursue her doctorate of philosophy degree at Cambridge University in the fall of 1932. She attended lectures which were taught by John Desmond Bernal, who was studying the structures of metals using X-ray crystallography, and became one of his research assistants. In 1933, the primary research interest of Bernal's group was shifted from structures of metals to structures of pepsin. From then on, Dorothy Hodgkin concentrated on the study of structures of biological molecules using X-ray crystallography, and determined to become a biochemist. In the spring of 1934, Dorothy Hodgkin received her doctorate of philosophy degree in biochemistry from Cambridge University. She then moved back to Somerville College and became a research fellow in 1934. In 1934, Dorothy Hodgkin continued the research she began at Cambridge with Bernal on sterols and other biologically interesting molecules, with the money she collected for an X-ray apparatus with the help of Sir Robert Robinson and the assistance of the Rockefeller and Nuffield Foundations. Her molecule of choice at the time was insulin. At first, this research occurred with 1 or 2 research students. Later, Dorothy Hodgkin would become the leading practitioner of the use of X-ray crystallography in determining the three-dimensional structure of the complex organic molecules. X-ray crystallography is a method of determining the arrangement of atoms within a crystal, in which a beam of X-rays strike a crystal and diffract into many specific directions. From the angles and intensities of these diffracted beams, a crystallographer can produce a three-dimensional picture of the densities of electrons within the crystal. From this electron density, the mean positions of the atoms in the crystal can be determined, as well as their chemical bond, their disorder, and various other information. However, Hodgkin's most significant scientific contributions were the determination of the structures of penicillin, insulin, and vitamin B12. Her work on insulin began in 1934 and has been impactful ever since. Insulin, which is created by beta cells and released into the bloodstream, is used to help the body use or store glucose it gets from food. Her work on the determination of the molecular structure of penicillin, which occurred in 1942 during World War II, is influential today due to penicillin's use in bacterial infections. Her work on determining the molecular structure of vitamin B12 began in 1948. Vitamin B12, which like other B vitamins, is important for metabolic processes, helps in the formation of red blood cells, and is crucial in the maintenance of the central nervous system. In 1956, Dorothy Hodgkin was awarded a Royal Medal. The 3 Royal Medals, also known as the Queen's Medals, are awarded annually by the Sovereign on the recommendation of the Council of the Society. Each year, 2 medals are awarded for the most important contributions to the advancement of natural knowledge, in the physical and biological sciences respectively. A 3rd medal is awarded for a distinguished contribution in applied sciences. Much later, in 1964, she won the Nobel Prize in Chemistry for her determination of the structure of important biochemical substances, such as vitamin B12 and penicillin, by X-ray techniques. Following her Nobel Prize win, she was awarded a Copley Medal. The Copley Medal is the Royal Society's oldest and most prestigious award, having first been awarded in 1731. The medal is awarded annually for outstanding achievements in research in any branch of science. The award alternates between physical sciences in odd years and biological sciences in even years. Lastly, in 1982, she was awarded a Lomonosov's Gold Medal for outstanding achievements in biochemistry and crystal chemistry. The Lomonosov Gold Medal is named after the Russian scientist and polymath Mikhail Lomonosov. The medal is awarded each year dating back to 1959 for outstanding achievements in the natural sciences and the humanities by the USSR Academy of Sciences, and later the Russian Science Academy. The two medals are awarded annually, one to a Russian scientist and one to a foreign scientist.
Dorothy Hodgkin had accomplished many things outside of science. She was president of the Pugwash from 1976 through 1988, which was a post-World War II organization that gathered scientists from all over the world to discuss and promote peace. One of its main focuses was the disarmament of nuclear weapons. She was vice president of the Medical Aid Committee for Vietnam in 1965 and became president in 1971, so she frequently visited North Vietnam. She also publicly voiced for issues in South Africa and Communist China. For her humanitarian work, she won countless prizes and recognitions, including the Lenin Peace Prize from the Soviet Union. Aside from her humanitarian work, she also was the second largest serving chancellor for Bristol University. She was chosen by the students in 1970 in a time when the university had heavy student protests and activism. She gave a commemorative speech, which many attendees described her as speaking in a quiet but resonating voice. Hodgkin had many acquaintances, including the Iron Lady Margaret Thatcher. Prime Minister Thatcher was tutored and mentored by Hodgkin as a student in Oxford, and on her fourth year she worked in Hodgkin's lab on a molecule called gramacidin S, which had antibiotic properties. Thatcher would frequently say that one of her biggest accomplishments was becoming the first chemist prime minister. She was also the first woman prime minister. Hodgkin had many scientific colleagues, but she became lifetime friends with Linus Pauling and his wife, who were also heavily involved in humanitarian activism.
Dorothy Hodgkin grew up in one of the most turbulent centuries the world has ever witnessed. Sexual discrimination in the workplace was rampant in Britain until the 1975 Sex Discrimination Act was passed. But this did not stop Hodgkin from attaining her bachelor's from Oxford by the age of 22 and her PhD from Cambridge by 24. She had many great achievements as discussed earlier, such as being the third woman to win the Nobel Prize in Chemistry, and was the first woman at Oxford to receive maternity leave, and also the Chancellor of Bristol from 1970 to 1988. She never let the ways of the world hold her back from succeeding in every aspect of her life. Dorothy Hodgkin was completely against the Cold War nuclear arms race and actually played a large role as president in the Pugwash movement from 1976 to 1988, and their attempt to convince the world's nations to stop the arms race. Despite the fact that Dorothy Hodgkin's protege, Margaret Thatcher, was Prime Minister of Britain and a pro-nuclear activist, when Dorothy received the Order of Lenin Peace Prize, she traveled to the Soviet Union to accept the prize. Dorothy Hodgkin was also denied a visa to the United States because she was part of a peace group that included communist countries. During the Vietnam War, Dorothy Hodgkin visited communist Vietnam to lend medical aid and to take a stance against the war. Dorothy Hodgkin's greatest controversies arise from her stubborn and motivated nature to do and to fight for what she believed in, regardless of who opposed her. She never let any social standards or gender inequalities stop her from being one of the most decorated and successful scientists of the 20th century.
Dorothy Hodgkin developed rheumatoid arthritis at the age of 24, which crippled her hands and feet. She would eventually have to be in a wheelchair as her condition worsened. Still, that did not keep her from her scientific work and humanitarian activism. She married historian Thomas Hodgkin when she was 27, and they had 3 children together. She retired at the age of 67 and passed away July 29, 1994, from a stroke. Not only did her contributions help with the advancement in science by introducing innovative techniques for characterizing biological structures, such as crystallography and computational analysis, but she also left her imprint as a humanitarian fighting for peace all around the world.